Hello everyone. Today we will see a 8051 program to find number of ones and zeros in an 8-bit number. So here suppose we want to count the number of ones in a given number. Say we are using the number as 100011101. Now here the number of ones in this number is 4 and the number of zeros is also 4. And we want to store the result in any of the register. Here suppose we are using the register as R5. Now to do this or to write the program for this, we will we have to store the number in the accumulator, and at a time we will rotate this number in the right direction or the left direction with carry. So for that we will use the instruction rotate right or rotate left through carry. First we will see what is this instruction. Suppose we have a 8-bit number, okay, that is 0, 1, 2, 3 up to 7, and we have a carry bit which is represented by this C, that is the carry flag. Now we will rotate the bits in the right direction. So we are rotating the bits in the right direction. The LSB, it will be shifted into the carry flag, and the bit which is in the carry flag, it will be shifted in the MSB. Okay, so the new MSB is the bit from the carry flag. This is the rotate right through carry instruction. Okay, we have a 8-bit number. We are rotating the bits or we are shifting the bits towards the right, and the LSB will be moved to the carry bit and the carry bit will be moved to the MSB. So the new MSB will be the carry bit. This instruction we will be using. Now to do this we require what? Rotate right through carry instruction, that is RRCA. Suppose we have a number 43H, that is 01000011 in the binary form. Now here this is our 8-bit number. The bits are 01000011. Now when you rotate this one time with say rotate right with carry, in this example here the carry bit, the LSB bit will be moved into the carry bit, that is the carry flag. Okay, and this carry flag or the carry bit, it will be moved to the MSB. Carry bit will be moved to the MSB. So the new MSB is the carry bit. Okay, so similar way all the bits will be shifted. Now it will be done for these all 8 bits. Now suppose if the carry is 1, okay, we will increment the contents of the carry flag as 1, and for this we will take the register R5. Initially we will initialize R5 as 0, and after rotation if the carry flag is 1, it will be incremented by 1. Now here the carry flag is 1, so it will be incremented by 1. Now next time in the second rotation, when again this bit will move here, again the carry flag will be 1, then again it will be incremented. Okay, then now the rotation here we are not interested in the MSB bit. Okay, we want to check only 8 bits because we have taken 8-bit number. So we need to perform the operation 8 times. For that we will take R7 register as a counter. Okay, so here it has to rotate 8 times. Now as we want to check the 8 values, whether those are zeros or ones, we have to rotate it 8 times. So counter should be initialized as what? It should be initialized as 8, and here we will use the register R7 as a counter. Now we will see the flow chart of the program. What is the flow of the program? Here we will start, and hence here we are using R7 as the counter, and we will initialize the counter with the number 08 because we want to rotate the 8 bits. Okay, and here The result we are going to store in where R5, and so R5 is initialized with the value 00H. Now the number which we are using for this operation, we need to store that in the accumulator. So in the accumulator we will be storing the number. Now we will perform rotate operation for the first time, and we can use rotate left or rotate right with carry. And if the carry bit is 1, we have to increment the result in the register R5 by 1. Here what we are doing, we are checking whether the carry bit is 1. If it is 1, then increment R5, okay, and decrement the counter, as we have performed the rotation operation one time and we have checked 1 bit. So after increment of R5, we have to decrement what? We have to decrement R7. So we have to check whether R7 is 0 or no. Now here we have checked whether the carry bit was 1. If it is 1, then we have incremented R5 and decremented counter. Now if the carry bit is not 1, okay, if no, then what we have to do? We should not increment the R5 register, okay, the contents of the R5 register. Instead, we will directly decrement the counter. Now, if the counter, if the counter is 0, it means all the bits are checked, okay. So if the counter is 0, it means that all the 8 bits are checked and the program will end. If the counter is not 0, then what happens? Here it will go again to this point, okay. Then again it will rotate the bits, that is, it will shift the bits. Again it will check through these whether the carry bit is 1 or no, okay. If it is 1, again it will increment, then it will decrement the counter. If no, it will directly decrement the counter, and it will be done 8 times until and unless the counter, that is R7, becomes 0, okay. So this was the flowchart of the program. Now to start with the program, here these 3 instructions remains the same, or instead of this you can use ORG0000H. Now, so the first instruction here is move A, #43H. We have to store the number in the accumulator. So because we want to perform what? We want to perform the rotate right through carry, which will work on the accumulator. Now here we want to count the number of ones from the given number. So we can use any number, that is any 8-bit number can be used. Suppose here we are using 43, okay. So now here first you have to save this 43 in the accumulator, fine. Here we are we are storing the number in the accumulator. After that what we have to do? We have to initialize the counter, okay. Now here to initialize the counter, we have used R7 register. You can use any other register also. So we will initialize the counter with what? 08. For that we are using move R7, #08H. Now the result, that is the number of ones, it will be stored in the R5 register, and that must be initialized with 00H. Now we want to rotate left or we want to rotate right with the carry operation, and hence here we are using what? We are using the rotate right with carry, that is RRC operation or the instruction. For that we will write RRCA. Now after this we will check the carry flag. So we use the instruction JNC for that, that is jump if no carry. So if the carry is not there, it has to jump to the label 1 here, okay. But if the carry is there, it will jump to the next instruction, that is what? That is increment R5. We want to increment the result, that is we want to increment the content of R5. Now after that what we have to do? We have to decrement the counter, that is DJ NZ R7. So, and we have to check whether the counter is 0 or not. So we will use the instruction here DJNZ R7 and check whether it is 0 or no. Now this instruction will decrement R7, and if it is not 0, it will go to the level up. Okay, if R7 is not 0, it will jump to the level up. So if R7 is not 0, it will go to the level up, and if R7 is not 0 again, we want to execute the rotation operation. So we will write there what? Here we will write level up. Now if the carry is there, we will increment R5 and decrement the counter, and if the counter is not 0, we will perform the rotation operation. But if carry is not, we don't want to execute this instruction, but we want to decrement the counter. So we want to jump to what? We want to jump to DJNZ R7 comma up. So the level L1 should be given to this instruction. So this program will count the number of ones in the given number, and the result will be stored in R5. So this program, it will check the number of ones. If you want to check the number of zeros, just you have to make a slight change here. Instead of using JNC, that is jump if no carry, you have to use jump if carry, that is JC you have to use. Then it will count the number of zeros. So here we are giving the input number as 43. Its binary is 01000011, and output we should get in R5, that is the number of ones should be 3. 1 2 3, that should be stored in R5. Here you can change your number. You can use any number of your choice. I have used here 43. You can use any number. Now we will execute the program. I will copy the program from here. So open the Keil software by double clicking on the icon. Maximize it. Go to project, new MuVision project. You can create your new project, or you can use the previously used project. I will use the previously used project and save. And click on yes, because I have used the previously used project, and search here for 8089 C51. So here you are getting 8089 C51. Select this and click on OK and click on no. Now go to the file, new file, type your program here. I'll directly paste the program. Now you have to save the program. So this program is counting the number of ones. I will save it as ones. You have to save this with the extension .asm. So when you save this with .asm extension, here the color of the mnemonics will be changed. Now go to the target, click on this plus symbol of the target. Now right click on the source group 1 and click on add existing files to group source group 1. Search for your program. It is ones.asm. Click on add and close. Now check whether this program has been added to your source group 1 or no. Click on this plus symbol. So it is added in the source group 1. Now go to the project. Click on build target. Okay, here you are getting syntax error. So here we will see what is the error in line 4. Move a comma hash 43h, and in line 8 it is up RRC. So again I'll save. I'll go to the project, rebuild all the targets. So in line 7 I have the error. Click on save, go to project, again rebuild all the targets. Okay, here it is showing that in 10 you have like a error, And in line 7 also you have an error. What is the error here? I'll save it. I will rebuild all the targets. So here you can see the errors are been removed. So you can see here it is 0, it is having 0 errors and 0 warnings. Now go to debug and click on start or stop debug session. Okay. Now again go to debug and click on run. Now stop the program. So here in R5 we have to check the answer. In 43 what we were having? We have used the number 43. So here the number of ones is 3. That must be observed in R5. That is, it must be stored in R5. So here we will see our result. In R5 we are getting it as 0, 3. So the number of ones is 0, 3. We will click on start or stop debug session. Now we will see for number of zeros. So here what we have to do? We have to do a slight change here. Instead of JNC, we will use JC and see what happens now. So save this, go to project and rebuild all the targets or build targets. We go to project and rebuild all the targets. Okay. So go to debug, start or stop debug session. Okay. Now again go to debug, run, and you have to stop. So in R5 you can see you are having 5. So according to this number, the number of ones is 3 and the number of zeros is 5. 1, 2, 3, 4, 5. So here we have checked for number of zeros. So the number of zeros are stored in R5, that is equal to 5. Hope you have understood the program. Thank you.